I love this problem. This is an excellent application of something that was learned in Algebra 1, which is substitution. We're dealing with two variables here. And um, so this is a system of equations. So what we've got is it says that for what values of x and y are the triangles congruent by hypotenuse leg? Well, going on, okay, well, let's assume then that they are congruent by hypotenuse leg. Then we can take the two um, algebraic expressions for the hypotenuse and say that is equal to that. Because if they're equal by hypotenuse leg, then those lengths are equal. We can then go further and say, okay, if that's true, then we know that the length of that leg in algebraic terms is equal to the length of that leg. Okay, so let's set those two things equal, and we'll get a set of equations with two variables. So we've got 3y plus x equals the other one circled in red over here, y plus 5. Okay. Separately from that, we've got y minus x is equal to x plus 5. Okay. I'm going to juggle this around a little bit. I'm going to subtract y from both sides here just to simplify it. And we've got 2y plus x is equal to 5. Okay, I'm going to take that simplified expression there and leave it for a second, or simplified equation rather. And over here, I'm going to say, let's do plus x on both sides. Because what we're going to do then, if we do that, is we get what y is equal to. Y equals 2x plus 5. Now this is going way back in the archives here for your learning, but we can't solve an equation with two variables. We can't solve this equation with two variables. If one changes, then the other will change accordingly to be able to continue to be equal, and we can never nail it down to a single value. But since we know that both of these equations here, this y value is the same here and here, and this x value is the same here and here, we can actually use these together. And what we're going to do is we're going to use the substitution method. And what the substitution method says is if we know what y is equal to this expression, 2x plus 5, then anywhere we see y, we can replace it with 2x plus 5. How does that help us? Well, let's take this and let's say 2 parentheses. What is y equal to? Y is equal to 2x plus 5 plus x, that's still coming down and being the same, equals 5. And now we're going to distribute this through. 2 times 2x, 4x. 2 times 5 is 10, plus x equals 5. And we combine like terms and we get 5x plus 10 equals 5. And if we subtract away 10 from both sides, we get 5x equals negative 5. Taking 5x and dividing by 5, and taking negative 5 dividing by 5, we find that x equals negative 1. Interesting. Because now that we know that, we can then go back to the other equation and we can replace x with what it's equal to. Typically, you go back to the original equation. So I could say y minus x equals x plus 5. Wherever I see x, I'm going to write negative 1. So I say y minus negative 1 equals negative 1 plus 5. And this becomes y plus 1 equals, and what is negative 1 plus 5? It is 4. Now we're going to subtract 1 from both sides. And we get y equals 3. And so we have a solution that x is equal to negative 1 and y is equal to 3. If we wanted to do a proof, we could go back to these original equations here and write them first, and then put parentheses wherever you see y and wherever you see x. Anytime you see variable, put parentheses, and then put the value that you think it's equal to inside, put -1 in for x, put 3 in for y, and see whether when you simplify it all down, it results in the same number on both sides. I'll leave it to you to do that, but that's how you solve this. So we're good to go.